So welcome on this Orbit meets Compose talk. I'm Škrášek, and I would like to talk today about our design system called Orbit. And before I start, I would like to ask you who is using Compose, or yes. And the rest of us, do you know what Compose is? Yes, somebody at least. So you are at the right place, right? Today we will talk about the differences and difficulties in our design system and material components system. And after a quick introduction, I will talk about the challenges we have met in our own experience with Orbit and Compose. So basically, the main topic will be the material components challenge, but we will cover also other challenges. And in the end, I will tell you something about the personal experience from migrating to Compose in our company. So what is Compose? It's new functional UI toolkit, which is directly in Kotlin, natively in Kotlin. That's the biggest difference. So if I would like to render the image on the right, the label and the button, all I have to do is call the function, which is called myScreen here, and the function will call other functions. So the biggest difference here is that the new UI toolkit is fully functional. There are only functions. There is no inheritance, therefore. That's good, right? When you want to change the content of the screen, you have to re-render, recall, recompose by calling those functions. And to do this easily, the best thing is to have your data modeled as reactive streams. The difference to SwiftUI is that Compose is totally created as a new library. SwiftUI tries to wrap existing components in the iOS environment, but in Android world, text inputs and so those are new components written directly in Compose. The good thing is that we are able to combine the old UI view toolkit and the new one. What is Orbit? Orbit is our own Kiwi's design system. It is mainly for our own usage, but obviously you may use it for your mainly travel products. It's open source, and it's not just about the Figma, but we have implementations for React, Web, and obviously for Swift. And today I will talk about our own Android implementation in JetPack Compose. The JetPack Orbit Compose library is also open sourced, and we have the documentation, the Orbit documentation, not Orbit Compose documentation, is at orbit.kiwi. So Orbit consists from many components. Obviously, we need those basic building blocks. There are buttons, switches, text fields, everything you can imagine, everything we need in our travel app. So you may see that even we have some specific components like the seating or some advanced choice styles components for users to choose from our options. But the design system is not just about those components. We need some foundation. We need to build upon something. So we need color system. We have it. We need some typography scale. That's also here. We have specific icons for travel products. So if you need some specific baggages icons, you are at a good place because we have plenty of them. Obviously, we have many illustrations which are, once again, travel related. So why use Compose for our Android Orbit design system? What was the driving force here? So obviously JetPack Compose is the next big thing, and we want to be on the same wave as Google is. They have invested a lot into this. We really prefer using composability over inheritance. This basic pattern in model layer is applied also here, so that's a great thing. It was a chance to restart the development of Orbit in our team, so we use it. And obviously there are many other plenty features we like. So how to build this design system? Basically, we need to synchronize those basic foundation resources to be in sync with other teams. So how to get our colors into the Orbit Compose? That's not so difficult. We download the JSON and then we generate a Kotlin class. We use Kotlin Poet. Quite easy. Icons are a bit more difficult. Our designers are exporting those icons in SVGs, and we need to convert them to vector drawable. And we need to do this automatically every night. So the ideal is to use the library, official library from Google, which is able to convert those SVGs to vector drawables. Last but not least, illustrations. We download them as PNGs and do the resizing every night. And if there is a change, our automation will open a pull request and we will review it the next day. So this is the first challenge, right? Can we build our design system without material components? So what is the answer here? Yes, we can, definitely, and that's what our designers think. That's what they want to do, to build own design system, not to be dependent on the material components, right? So this is great, but in the end, the real answer is no. And I will talk about this. So why we need material components, or at least somehow work with material components? So first of all, we have those basic components like buttons, form fields, tabs, right? And those components we don't need. Obviously, our designers have designed custom appearance of these components, so we have our own and we don't material for this. But then there is a text component, the composable text component, and it's in material package. This is quite a big package. And actually in material 2, there is a bug. I will talk about this later. So this is the first issue. Next, you would guess the icon is quite common component. It could be included directly in Compose. You wouldn't need a material for this. But it actually is in the same big material package. So icon and icon button is also there. Next, there is the ripple effect. So this is pretty much natural to all Android applications, even if they are not using material components. So we need this, but quite frankly, this is extracted to own ripple material package. So this is quite okay to use. Next, it's not just about those components. It's also about some behavior, something non-visual. So if you would like to implement your own switch component in JetPack Compose, you are free to do. But there is a lot of code which handles the gestures, the swiping, the behavior of swiping. And it's not short code. It's quite a lot of code. And it's quite difficult. You don't want to write it on your own. And it's also in this big material package. Next, there is the swiping or scrolling behavior for the navigation bars, top-up bars. So next big thing which is included directly in material. And we need this in our own design system. So this is what we don't want to do. We don't want to expose that we are using material, and we don't want to expose to our users that there is also a material library they might use. So the first option here is to use the wrapping pattern. So we are doing so, but it's not nice. Just make it an internal dependency and wrap it to our own components, which we'll use in the end the material implementation. The second option is to copy the code, copy paste. And we are doing so as well, but also not a good solution. And there are no other solution, or we are not using other solution. So let's compare the Orbit design system with the Material 2 design system. You can see the typography scale is totally different. You have different numbers of those headings, body styles. Also, not only different number, but those scales are different. The biggest title in Material is totally different than the biggest title in Orbit design system. How to solve this? We are creating own typography class, which is part of our own Orbit system. So when our users, I mean developers, are using the Orbit Compose library, they may reference all those styles we need them to know and reference. The same story is with colors. So we have about 6 colors, 3 or 4 shades. Material has different colors, and not only different number, but also they are calling those colors differently. So again, what to do? We don't use those material colors. We are creating own ones. We are making some tree structure here. So the top class is colors, and we have sub feature colors which reference those specific colors for many semantic use cases like success, warning, critical, and so on. And when you are using those colors, we are directly referencing orbit theme.colors. There is no material in the way. But as I have said, we need material, at least somehow, to be cooperating with us. So if you will start using orbit theme, in the end, we will set up material theme for you. This is what's happening underneath. So we will define also the material theme and do some conversion from our basic colors to some material colors to let the material theme to be somehow similar to Orbit design system. This is the conversion. So we have our own design system, our own definition of those colors, and we are converting them somehow to the material one. We know that the conversion isn't perfect, and in the end, when somebody will use material component, it won't be perfect, but at least it will be somehow styled similarly. The colors will be similar, the typography will be similar. You may see the H1 title isn't available in our Orbit design system, so we are defining those scales manually here. So about the text color issue, if you use material theme, the material theme, but also other components in material, will set up the local content alpha to some constant called high, local content alpha high. And this constant gets resolved in light theme to 0.87. And when the text in material will be resolving the final color of the text, it will take the wanted color and automatically apply the wanted content alpha. So in material, when you set up that the text color is black, it will automatically get lighter because this content alpha. And this is an issue because our Orbit design system doesn't work with this, right? Our designers are saying, this is the color, we want specifically this color. This is in material 2, it's not present in material 3. So we have our own text composable functions, and you may ask how you differentiate between them. What is the difference between the first one and the second one, right? And the only difference is in the import. So this may lead to some bugs and inconsistencies, and we need to solve it. So the first idea is to put some prefixes, Orbit prefixes, and use it all the way, right? So you would end up with screen when every function would be prefixed with Orbit. This is not nice. This is 90s kind of style. So rather not, maybe I may say it's Objective-C style, and we don't want that in Android. So other option is to set up Android Studio. There is a feature you may use inspections. There is the feature you set up some scopes, and you may say that all your application scope is disallowed to use something which is in scope in material. This works nicely. The code will be underlined, and your developer will know that he's using the wrong function. But in the end, this is not CI checked. Maybe there will be some options like Wadana, which will check the inspections on the CI, but I don't know, we haven't tried. Because there are other solutions, and I believe this is the best one to use linter solution. Either you may write some easy KT-lint rule. Writing KT-lint rules is really easy. Then there is detect, or in the end, Android lint. Currently, we have those rules in KT-lint, but I would recommend to use Android lint because everything works nicely on CI, but with Android lint, you will get underlining in ID for free. So this is probably the best option. You may somehow make it work that detect rules are also underlined, online evaluated in ID, but Android lint, this is for free. So this is our next step to integrate, to rewrite those lanes for Android Lint and publish them directly with the Orbit Compose library, that every developer would get this for free. So, as I've said, we are using wrapper pattern. We use icon, we have custom icon, which is wrapping the material component. We have top up bar, which is wrapping the accompanist component, which adds some instant handling and so. And this is the best way you can do, basically, because when there is a bug, you can fix it for free and you don't have to rename everything. As I have said, there is a bug in the material icon implementation. It does wrong intrinsic measuring. So when we have met this bug, we have just rewrite the icon implementation in Orbit Compose and suddenly everything was fixed. The same way, our original top-up bar was dependent on accompanist implementation. In the end, we have introduced own implementation and we didn't have to replace all those definitions of top-up bar. Another good reason to use wrapping is that there is no center styling in XML like before. So if you need to change some styling in your app, ideally you have to have the single place your wrapping function. Next challenge is the API, how to design those components in JetPack Compose. So we have a button and obviously we have many kinds of button, primary, secondary, and so on. The first thing you may come up is putting those kinds after the function name, and you will get something like this. Next option is to create an enum or sealed interface and pass the kind as an argument as a function. So we have chosen the first way, and this is the reason why. First of all, it's shorter. This is different to SwiftUI. In SwiftUI, you can use some dot prefix and you can omit the enum kind. This is not possible in Kotlin, so basically using this way, we get the definition shorter. Second, there is no strong need to mutate between those kind of buttons. If there would be the need, it would be more natural to put it as an argument, but because we don't change primary to secondary buttons quite often, we are using this style, which is also the official style in material. You have two text fields and the only difference is the visual, but they are creating two functions for this. And as we have realized after the decision, also the Figma is showing the component name similarly to our implementation. So I would say it's also ideal for our developers. So we have solved the API design challenge, but still there is naming challenge, the most difficult thing in the world, right? So there is the Android world, there is the Orbit world, and we need to somehow move in those areas. First of all, Orbit have been developed from React world. So, for example, input field and text area is really related to the HTML implementation. But in Android world, this is the single component. So we are keeping the Android world naming here. Similarly, the navigation bar is something iOS-like, because on Android the navigation bar is underneath the application, but we are talking about the thing on the top, right? So we are using the Android stuff here. But also, Android may have single component for multiple purposes. This is the example of chips. And in Orbit Design System, we have multiple components here, so we are keeping the name from Orbit Design System. Dark mode challenges, oh yeah. So we are just dark mode aware. We are not dark mode ready. The biggest issue here is that Orbit Design is not ready for dark mode. We will be, but not now. But as the developers, we are trying to think about this dark mode, which will come in the future. So what we are doing, we are trying to keep those things named semantically. And this will help us in the end to migrate to dark mode. So for example, orange colors are not called orange colors, but warning colors. And the same way, we are not telling our developers there is light color, it's rather subtle, or in case of darker, it's strong color. Slotting API pattern. So On the right side, you see our batch component, batch warning component, and then as you may see, then can be a label, icon, or both of them. So the ideal solution may be the second example in the code, that user would just pass the string and the icon. But we are trying to match the recommendation, which is telling us that you should use slotting for all cases. The slotting is more open to developers, so we have to believe our developers that they won't misuse it. They won't put something else that shouldn't be there. And we are allowing to put them something composable, the whole composable lambda here, and to use the slot. And those slotting APIs may help us later. And one of those examples is the UI testing challenge. So when you want to UI test something in Orbit Compose, you may put a tag, and later you will ask the testing framework to retrieve the composable by this tag name, and you perform an action on it. So for example, we have text field which consists of multiple things. It's the label, the text field itself, and the error message. All this is included in the text field composable in Orbit Design System. But you may want to check what is the error message. And if you would choose or find the component in tree just by the name of the text field itself, you would get many texts. You would get the email, you would get the inputted value, and you would get the message as the last text value. You would get a list of texts. This is not ideal. You would have to know what can be the error message. So basically, you need to mark the error message somehow. And this is the case when the slotting API helps you, because when you have a slot, you may put custom modifier to the error message, and later you will just read the error message and its text value. Well, yeah, documentation challenge is the biggest one, right? So we know we have to write something on orbit.kiwi. It's not done yet. Well, we should write more k-dots. We should definitely put some previews. And this is what we need to do, but what we have actually is catalog application. So you may go to Google Play and look for Orbit Compose catalog, and you get the whole application. And the whole application is not just for developers, or ideally it's not just for developers. Our designers may use it too. So when they are not sure if we have something implemented in Orbit Design System, they may check it up. They may check if the implementation is the correct one. And that's about it. So our overall experience is that the JetPack Compose was not and is not fully production ready, but we are using it, right? So there are plenty of issues we have, mainly the preview issues, because the performance is really low. Keyboard issues, a lot of issues. Many of them will be fixed in Compose 1.2, but you know, they will introduce others. Because this is quite new framework, so issues are there quite naturally. So the conclusion here is wrap all third-party components to own wrappers. Use them all the time, even if you don't need them at the time. And if you have a design system which is different to material, definitely create custom theme and use the custom theme. Prefer slotting API, and when you are using slotting API, you may focus on creating rather building blocks than creating high-level components, and this will help to your developers. You know, because designers don't know the product. I mean, Orbit designers don't know the product for every screen. There may be some use cases they don't know about, as well as don't know about those use cases. So slotting API helps here to create those basic building blocks. Introduce custom length checks. This is also good for other stuff, not just UI stuff. And if you are migrating your app to Compose, I recommend to do it in two steps. First, just rewrite those views, and if you have finished, you may continue with those fragments and migrate to JetPack Compose navigation or something like that. So that's all. Thank you, and I'm expecting many questions. So, okay.
Okay, so is it just an internal stuff, or
So Orbit Compose is public stuff. Oh, I should repeat the question. Is it internal stuff or is it used in production?
Like,
I know.
You just develop it and it's just for testing, or did you already put it into the TWI app?
So the question is if we are using this in production basically, and the answer is yes. And not only in production, we are also publishing this in open source, so other people at least have tried to use it. I don't know what is the result, but yeah, we use it about, I don't know, 9 months. We have Compose for 9 months in production. Yes. So, second question.
Yeah, I wanted to ask, you mentioned that you are not using material or imports at all.
So the question is if we are using material imports. Yeah, that's the approach we are trying to use. Obviously, if we really need to use it, we may put a suppression, locally suppress the length check. So that may happen. For example, I don't know. I believe material dialogues. If we are using material dialogues, we need to import some text buttons for material. So that's the case when we are suppressing the length. Okay.
So what's your overall feeling of JetPack Compose in general? I mean, was it worth it, like putting it into your project, or do you feel like you saved time, or you opened door to new opportunities, or what's your feeling about it?
So the question is about the feeling, how we use it, how we are satisfied with the JetPack Compose, right? So the answer is we are pretty much satisfied. The biggest difference is that we are using the composability pattern, which was quite difficult in the old times. So we are able to build many components right away. That wasn't the case before. We had just a button or something like that and some foundation stuff in the old UI view toolkit. In JetPack Compose, we have plenty of those components, as you may have seen. So overall, we're really satisfied with the speed we are able to build our components. Yeah, we have some problems like keyboard and focus handling and so on some screens when there is more text fields and multiple input fields. This is a bit rough, let's say this, but overall, we are totally satisfied, and some teams have migrated all of their stuff to JetPack Compose, and they're pretty much satisfied with this.
Cool, thanks.
Welcome. So, any other question?
We have one question,
Okay.
Slido, from Notchmola. When will Orbit be ready for dark mode?
Well, the question dark mode and when will it happen? Okay, I don't know. I guess we could make it in a month. I mean, we as a Orbit Compose developers, but we need to wait for our designers to make some decisions, and those decisions haven't been done yet. So that's the biggest issue. What would I say that the biggest help is the pattern for the material, which is called surface elevation, which works the way that in the dark theme, instead of casting shadows, they're lightening those surfaces. And this is not included in the Orbit design system. So either we will use it and it's not an official usage, and then it will work quite nicely, or we will have to wait for some colors adjustments from Orbit designers, and then we will implement them in Orbit Compose library. Okay, next question.
Did you experiment with multi-platform?
No, question, have we experimented with multi-platform? We have not. Yeah, this is just Android library. Okay.
Have you noticed some performance improvements in development? Or did you
What do you mean by performance improvement?
Like, if you measure something like our developers right now are 10% faster than before.
So the question is if developers can develop components faster or screens faster. Yeah, we didn't measure this, but I would guess they do so. But it also depends if those components are prepared in Orbit Compose. We're still in some alpha phase, let's say it this way. So not everything which is defined in Orbit design system is ready in Orbit Compose library. but in the end, we try to cooperate, and I would say that they develop those features faster. What may be also easier is to, UI testing is less flaggy in UI testing mode, so Compose is less flaggy. So this may help to find those issues in UI testing scenarios and so. Next question is here. Okay, non-question.
Did you face any challenges when you were trying to use the color system with vector drawables?
So the question is about vector drawables and colors. And what is the question actually?
Because,
What kind of challenges do you mean?
well, previously, if you can, when you define the colors in material theme, if you like primary color and so on, if you can use these colors in vector drawables when you want to apply colors to some parts of your vector.
Well, so the question is if we use color definitions in vector drawables. So we do not, because the vector drawables are just with the black color, and we tint them when we are using them at the place when we want to use them. So the icon composable has the tint parameter, and we just use the coloring here. We don't change colors for the vector drawables. And to be honest, hopefully we will migrate someday to the native way of drawing vectors. This is what Material does, that they're not using vector drawables, they are using directly those drawing commands, drawing functions. And this way, I believe the tinting is the best option probably for us. Yeah, if those icons would be too colored, then we would have an issue. But
That's what we face.
thanks God we don't have two colored issues, two colored icons.
Is there possible some integration between Figma and Orbit Compose?
The question is about integration between Figma and Orbit Compose or Compose itself. Well, I believe somebody sent us some links about this, but we are not using those. I don't think it's somehow worthy or valuable. I don't know. Maybe if somebody has experience with using this, let's talk.
I know that it's in development, but I'm not sure if it's ready to use.
Okay, is it all? Thank you very much.